Another week, another really cool paper has been published, and this one is quite ambitious because it tries to replicate human behavior across domains and suggests an agent architecture that simulates the attitudes and behaviors of over 1,000 real individuals. And what's actually interesting about this paper, at least for me, is that do you remember this paper about generative agents, which was published back in 2023 by the collaboration of researchers from Stanford and Google? I really loved that one. So actually the new paper is done by more or less the same team of researchers from Stanford, but I also see here, for example, Meredith, she seemed to be part of Google over here. Anyway, same people. So we will see some interesting overlapping concepts. So let's look at this paper and also what we can learn from the code, what kind of techniques they are using to work with agents, especially since they're trying to predict human behavior, and this can be as cool as it is creepy, to be honest, but also very exciting. So let's look. So the architecture which is described in this paper is designed to simulate the attitudes and behavior of real individuals, and they actually took over 1,000 people. They designed the questionnaires, and then they interviewed those people, and then they compared the response from the agents, which were kind of given all that information and were also conducting those interviews, and the real people from that experiment, and they concluded that the responses aligned with 85% accuracy. So this is pretty cool, and they suggest that this architecture can be used to investigate individual and collective behavior. So each of those human beings who participated in this research had to go through a 2-hour interview where an AI interviewer was asking them questions about their life and their experiences and kind of building that picture around them. And based on that, they built an agent bank, and we have partial access to that agent bank. We will see what information we have in the GitHub repository, but we have some good examples to get the picture what kind of information they collected and how they used it. For the interview, which every of those human beings had to go through, they had the same structured approach where actually the AI interviewer, an agent, was able to shape the questions according to the story of that person. After the interview, the participants, the real human beings, had to go and do some surveys, and we will see those later defined, and go through some kind of questions and some other evaluations, doing some behavioral experiments, playing some economic games, and other things. And based on those interviews, the researchers built generative agents, and then they gave the same surveys, the same games, the same experiments to those agents to participate in, and then they compared those results. But not only that, the actual participants, the real human beings, did that twice, because we assume actually that humans, and I'm a good example, really have bad memories. So, or no, they change their minds. I don't know how to explain that we can answer the same question differently within some time span. So the researchers looked at it and said, okay, they will do those surveys and the rest of the questionnaires and behavioral experiments twice, 2 weeks apart. So first time right after the interview and later in 2 weeks, so that we can see also how much the answers deviate for the same human, for the same person within that limited time span. And here we have that note that within the interview structure and time limitations, because each question had a limit. We will see later the whole questionnaire, and it will be a question and the limit of time allowed for AI to take discussing that topic. So within that time limitations, the AI interviewer dynamically generated follow-up questions tailored to each participants' responses. So they had the basic set of questions, but depending on what person was telling, they were either cutting it short when there was nothing else to discuss, or they were building up story based on that conversation. There is some information here about how they built the agents, and actually here they had also exploratory stage. But I was looking particularly into the memory part, which we will see later a bit more in the implementation. But I was looking because I noticed that in the implementation they're using embeddings, but I was not really sure how exactly and with which goal. And I was looking specifically for the semantic search, and here they do mention that they try to prevent exact answer retrieval. They use semantic search to find the most relevant information, and we will see later because they used also a model, an embedding model for that, and they stored the embeddings next to the interview answers. So this is the first part, and the second part focuses more on the agent bank and how they designed that interviewer and the general architecture of the agent, and how they conducted the surveys and experiments with those agents in comparison to human beings. In this study, they tried to form a representative sample of the US population, so every participant was based in US. Sadly, Ukrainians speaking English with strong accent were not invited. But every participant was accessing the system through the interface where they had to build their avatar, and I think that those avatars, they do remind me a lot about this paper, and there is also the demo for this one if you want to look back into it. And they had this interface to communicate with the AI interviewer. Talking about interview agent, we need to cover a couple of things. So first of all, as I mentioned, there was a list of questions, but the interview agent has this freedom of thinking on the spot and deciding if it's worth moving to the next question, or if they have enough time still to stay on this topic and dive a bit deeper, depending on what the participant was telling them. And once there was a response of particular topic, the agent, the interview agent, was also entering the reflection mode to process that response from the participant and maybe summarize it a bit, make it more usable when we have a lot of different information, so that we don't have a wall of text, but kind of we have a better organized stuff. And also it helps to keep the context window, so to keep all the information within the context window, and maybe not to use too much data when we provide this additional context to large language model. And this reflection mode, actually, we remember that from the previous paper, from the same researchers. So they are definitely reusing a lot of elements, and it's actually pretty cool that they are doing this. Here in more detail, they are talking about the amount of time that can be spent on particular question. Also here they are mentioning the prompt, that it can be too long and that it risks gradually degrading the performance of the interviewer in generating effective follow-up questions or decisions to move on. And to overcome that, they are doing these summaries of what the participant was telling us. What also I really liked that they're talking that for the interview, within that interview script, they were trying to satisfy two different goals. And first of all was to inspire meaningful answers, obviously. But the second one, they say that they wanted an interview script that was designed independently of their evaluation metrics by researchers outside of their team, to ensure that we do not unfairly tailor the content of the interview script to favor or align with predicting participants' responses to the specific surveys and experiments included in our study. And this is the first actually thought which I had when I was kind of reading what they have done. I'm like, you can actually ask questions and navigate that conversation knowing that this is things you're going to evaluate later. But they proactively avoided doing that by taking the questionnaire. So this is American Voices project, which you can access and read all those questions from there. and they used that one. They excluded some of the parts of the script because this one, I think it's 3.5 hours or 3 hours, and they aim to fit everything in 2 hours, so they excluded some particular topics. Another cool kind of things that they conducted with every participant when they started that conversation, they conducted an audio calibration by asking participants to read aloud the first 2 lines of The Great Gatsby. We also can learn which models they use. So they used OpenAI audio and whisper model. To generate reflections, they used a GPT-4o language model. They also go in detail for the prompts, which is super interesting. And I think that the structure of the prompts, again, relates to the structure of the prompts of the agents in the previous paper. When I was looking through the Python code, which they also have accessible for this particular paper, it was really nice to see how they design the prompts step by step. So they navigate a large language model to perform smaller actions and build up the response based on it. Also, I really liked how well structured their prompts are. So they indicate what is task description, what is interview objective, and they reference to the interview objective later. They, for example, say here not to go far away from the interview objective or like achieve it. So they always try to keep the model focused on the interview objective. What was interesting actually, and this is more related to the code, they didn't use functions to retrieve the response from the model in this kind of a JSON format. They just used it as it is, which is quite interesting because I thought that this would be the default usage when you want to have some kind of a structured response and validate that stuff. But maybe there were good reasons not to ask large language model, not to ask GPT-4o to return them a JSON formatted response. For the reflection modes, they also did something really cool because they not really just asked general information about the stuff which participant told them about. They asked for the agent to pretend that they are a domain expert, and they had 4 different domains for different sets of reflections: psychologist, behavioral economist, political scientist, and demographer. So this was kind of a cool, interesting approach. So instead of generic summary, generic reflections, they were getting very specific reflection within the domain of those 4 different experts. Funny, here they had to say that you do have a PhD, so you're not the person who pretends to be an expert, but you are a real expert. This is like the sign of a real expert. And actually here they describing their chain of thought prompting approach, which I mentioned they also used in this other paper. And here they divide the task into different steps. For the evaluation, they used the structured responses, which actually kind of a smart and easier way to compare the responses from the participants, the real participants, to the agents, because otherwise if they would be generating just text, both of those parties, it would be difficult to say how far apart it is. But if they're just using structured responses, like selection of the items or evaluating on a scale from 0 till 10, then it's easy to compare if the agents and the represented human beings are aligned in those responses and how much they are aligned. They do go a bit deeper in depth about the evaluation techniques. For example, this big 5 personality traits, which actually sounds really, really cool because it helps to predict a wide range of behaviors and life outcomes, from academic and job performance or to social relations and mental health. Then they also suggested several economic games, dictator game, trust game, public good games, and it evaluates behavior from different angles. Then we have some supplementary tables. Here you can look in depth about the demographics of the participants and the distribution. some more stuff which statisticians will understand better than I do. All these numbers drive me crazy. And finally, the interview script, and this is quite interesting because we can see what information the agent or the basics of that information were used to build this psychological portrait of the person. And some of those questions were quite deep. For example, tell me the story of your life. You have 625 seconds for that. Start now. Now let's look into the code. And I have it over here. And I already played a bit with it, so I can show you around. But if you want to run it yourself, you will find the settings file, and there are some properties which you need to fill in. I guess the most important one is the API key. And here you can select the model. This was by default, and I kept it. They, in the papers, mentioned that they actually using 4.0, so you can also experiment and see which one gives you better responses. Then we have GPT structure file, and this is where all the requests to GPT are formed. A couple of interesting things which I noticed here. They're using temperature 0.7. I'm not sure if it's the default one. The paper which we looked at last week, I think had lower temperature than that. Also, this is a place where I was wondering, because here they defined as usual roles, the content, but they don't define those functions which help to instruct GPT to return JSON response, a JSON body, instead of just a plain text response. And I wonder why they actually went with this as a default option, and maybe there is a reason not to use JSON for the sake of getting that response, which is actually quite interesting, because I did find this LM JSON parser, and that's kind of, at first I was thinking no, but they had to then use it for something, right? And then I realized it's used for some other reasons. And also I wonder, isn't it like in Python a normal library available for parsing JSON? Strange. With that said, they did have error handling and retries over here, so apparently they were ready that they need to send the request again, even though this is for the attached images, and we also have something for PDFs. I'm not really sure if this is super relevant for a normal response. However, next to it we have get text embedding. So this is actually embedding for a piece of information that is then transformed into a vector. And maybe it's actually a good point right now to look at an example of an agent. So here we have agent Pink. It does have only one agent with the complete information. Here we actually have June Park, who is the creator of the paper. Let me scroll up. So we have June Park, which is actually a pretty amazing idea. It's kind of putting information about yourself as a part of agent for the future of the science. Isn't it cool? So we have information about June here, and I hope I'm not mispronouncing his name. I'm very sorry if I do. Here we have a set of notes. This is a node type observation. This is interviewer asking questions and then receiving the answer to those questions. So we can see the interviewer, and we also have June answering and explaining stuff related to that question. In the file embeddings, we kind of have similar stuff, but each of the responses is actually embedded into a vector, and it's very long. Wait, let me find at least single one. I saw some, yeah, okay, here we are. So here we have the information from the interviewers, the response from June, and next to it we have this long vector, which later helps to find relevant stuff. Talking about memories, they do have different approaches for handling memory, and I found this quite interesting. Let's go to the memory stream. So this is the whole file with it. So they do have extract recent memories from the nodes, And this one returns a list of nodes that are in chronological order and outputs a dictionary that has the recency score calculated. We do have this last retrieved property, which is then used in the calculation to get the to extract the most recent memories. Apparently, this one I'm a bit, to be honest, lost, but we do have this recency decay, and I think that actually the recency, this part really played a big part when the agents were living in the small village. They were also, like, we were relying how often we are extracting certain memories, I believe, and then those memories were more important. But in addition to this extract recency, they also have extract importance, because some of the memories are more, or some of the nodes, some of those parts of description of a character are more important than others. And here in the interview, we can see that each of the nodes has some importance score. It sometimes, in my opinion, correlates with the length of the message. The shorter ones, they do have slightly less importance there, because probably there is less information within those. And then the last one, we have this extract relevance. This is where the embedding is used. How I see it is that they have a particular, so here they call it focal point, a particular idea, maybe something important in this particular conversation which a participant mentioned, or something else. And then they try to look for other ideas from the memory around this focal point. And for that, they embed the focal point into the vector, and they compare it to all the vectors which they stored in the JSON for the embeddings. Some other interesting methods include add node. So this is actually creating that part of a memory stream. And here we put all the information, all that last retrieved, importance calculated, on all the rest. So I went and I tried, even before reading the whole paper, to be honest, I'm that person who doesn't read instructions and tries to use the thing and then realizes I use the thing wrong, and then I read the instructions. So I did it somewhat wrong, but I still tried to run and create an agent. And the first idea in my mind, which I had, is have an agent, Marty McFly, the one from Back to the Future. With the help of ChatGPT, I created a scratch for that agent, then also added some memories there. I was a bit confused with the timestamp, but I guess it's kind of sequence of the events. And I was also asking some questions. For example, do you enjoy outdoor activities? And Marty said that yes. Then how much do you enjoy coding? Marty probably said, I have no idea what is coding, because it was like 1985. So apparently it's a very low score. And then when I saved Marty, I got a new folder with the memory stream from Marty. So here we can see similar as we had for June, with some content, importance, and the rest. We do have embeddings as well, and the information about Marty. So I totally used it not in a way how the system is designed for, because what I was supposed to do is to go through the interview questions and not just remember some random things by the agents. And maybe this is something I need to do next. Among other agents which we have in Agent Bank in this GitHub repository, we have a list of agents, but they have a very basic information about them. They do have information about them, like factual information, but we don't have embeddings and we don't have nodes. However, I still think that having one agent fully populated, like with June, is totally sufficient to understand how this library works and what kind of properties it produces and so on. And I'm still excited about the possibility to build Marty McFly agent and then later to talk to him.